last set of notes. So here is our basic equation, y equals a sine b, x plus or minus c plus or minus d. A lot of these things are exactly the same as our other transformations of our other functions that we've talked about before. So like here at the beginning, if this were negative, that means it reflects over the x-axis. Just like with any other function, you got a negative out in front of it, it makes it reflect over the x-axis and it goes down as opposed to up. The a value we dealt with in our notes last time, what was our a standing for? That is our amplitude. Your amplitude is how high or low your graph goes. That deals with our high-low. Remember, your amplitude itself is always a positive value, even if you have a negative out in front, like for example this one is a negative out in front, but your amplitude itself is still a positive value. So then our b, which we haven't really dealt with yet, that is your frequency. So that just means how many times is this graph going to occur. Frequency is how often. Your frequency does affect your period, which the period simply means how long does it take to get one entire curve. So one entire sine curve or one entire cosine curve. So for all of our graphs on the day 6 notes, your period was 2 pi. So from 0 to 2 pi, you got one entire curve. Your period gets changed based on your frequency. So then your c value here, that's what we call your phase shift. That's your graph moving left or right. And again, it's just like your other functions. When we move to the left, you actually add it. When you move to the right, you subtract. Those ones are always backwards. And then our last one here, our d, that's your vertical shift. So that moves your graph up or down. It also creates what we call the midline. Sometimes they refer to it as the wrap line. It means the exact same thing. On our graphs last class, your midline was always your x-axis. That went right through the middle of your graph. So sometimes they take that midline and they move it up or they move it down. So your entire graph moves up and down. So let's take a look at our equations here, and we're going to figure out our important aspects of it. So for the first one, our amplitude, our a value, so that's our value right out in front. Our amplitude here would be 3. P, which stands for period, that's the formula 2 pi over your b value. So if we look at our equation, your b value would be the 2 here. So our period would be 2 pi over 2, which reduces to pi. So with a period of pi, that means you're going to have one complete curve from 0 to pi. And then it repeats itself after that. But you get one entire curve in that period. So next we want to know, do we have a phase shift? And that would be the stuff in here in the parentheses. We do have a phase shift of 90. And that's going to the right because it was a subtraction. Our wrap line is that number at the end, and it's always a y equals. So our wrap line would be y equals 3. So then to find our range, you have to take your d value from your equation and add it to your a. That gives you one of the values. And then you've got to also subtract d minus a. So if I look up here, d remembers that last value. So my d here is a 3. Our a is also a 3. So I got to do 3 plus 3 and 3 minus 3 to find my range. So that gives me 6 and 0. So the way we write our range is always low to high in brackets. So 0, 6 would be our range there. Bless you. All right, so let's try the next one. Number 2. Again, amplitude. Amplitude is actually a positive value. It would be a positive 1 there. So you got that negative 1 in front of sign, but your amplitude is actually positive 1. What does this negative out here in front mean?
That it's reflected.
Good, that it's reflected. So our sine curve would normally go up, but because it's negative, that means our sine curve in that case would go down first. Our period, again, that would be 2 pi over our b value. B is in front of the parentheses right there. So what number is there that we don't actually write? 1. So our b is just a 1. So our period is just 2 pi. So from 0 to 2 pi, you would get 1 complete sine curve. Phase shift. We do have a phase shift again because you have something added directly to x. So this would be pi over 3 to the left. Our wrap line would be y equals -2. It's just that last number at the end. And then our range, again, you got to do d plus a. So -2 plus -1. When you're figuring out the range, you keep that negative with your a sign. It's just when you're figuring out your amplitude, that's only when it's positive. And then d minus your a, so -2 minus -1. So what would our range be? Yeah, so -3 would go first. Lowest to highest, -3 to -1. All right, let's see what you can figure out for the third one on your own. I'll give you a minute, see which ones you can figure out, and then we'll go over it. All right, let's see how we did. What's our amplitude? +2. How about our period? It would be 2 pi over 6, but I can't leave it like that. Definitely can't leave it like that. That's a big no-no. So remember, this is really like 2 pi over 1. So fraction over a fraction, we had to keep, change, flip. 2 pi over 1 times 6 over pi. So what will happen with our pi's? They'll cancel. So our period here is a 12. You'll get periods like that when you're dealing mostly with your word problems and they're talking generally about like a time. So your period here could be like 12 months or 12 seconds or 12 minutes or 12 hours. So that's generally when we get our periods that are numbers as opposed to what we had before with our 2 pi or our pi. Do we have a phase shift? Yes. Pi over 4 to the right. Our wrap line? Y equals 3, and our range? 1 to 5. Now, one other thing I want to point out with these when we're going to graph them. Questions 2 and question 3 are both in radians. What's our hint that they're in radians? The fact that these still have pi's in them. That's how you know those equations are in radians. Did my first one have that? No, it actually said 90. That one had degrees. So you have to be careful because when you're dealing with these, this question, your calculator has to be in degree mode because they gave you the problem in degree. These other two, your calculator would have to be in radian mode. So you're going to have to be starting to switch back and forth between your degree and your radian depending on how they give it to you. All right, let's do some graphing. So we have two graphs here. We got g of x equals cosine 1/2 of x. This one's kind of a basic curve. It's not our parent function, kind of like what you were dealing with last time, but it's a little bit more basic. So some things we want to keep in mind is, what is our amplitude for this one? 1. And we need to know our period. So 2 pi over 1/2. So let's clean that up a little bit. 2 pi over 1/2. Which is 4 pi. So our period for that one would be 4 pi. So now when we actually go to graph these, we use what we like to call key points. The key points would be your max, your min, and then your zeros right there in the middle. Those are our key points. So what we do, especially when the period changes from our normal one, is you got to figure out when are those key points going to happen. So you want to take your 4 pi, you take whatever your period is, and you divide it by 4. So here our key points are going to happen every pi. So at 0 I'm going to have a key point, at pi I'm going to have a key point, at 2 pi I'm going to have a key point, negative pi, and negative 2 pi. Those are where all my key points are going to be. And again, those are your highs, your lows, and your zeros. So now we have to follow the basic shape of our graph. Cosine, where does cosine start? Did it start at 0 or did it start at 1? Come on. Where does cosine start, 0 or 1? 1, good. Since our amplitude is 1, it's still going to be 1. So at 0, my cosine curve is still starting at 1. And then my curve would go down to 0, so at my next key point would be 0. And then it would go down to negative 1 at my next key point. And then it's got to go the other way. Okay, so then this one would go down to 0 at negative pi. And then negative 1 at our negative 2 pi. And then we connect and make our curve. So as I was saying on the front, our b value, which in this one was 1/2, that is our frequency. So if you look from 0 to 2 pi, I only have half of my cosine curve. I didn't get my other half where it goes back up. So that's what our frequency does. It tells you how many of those curves do you have there. All right, let's take a look at our other one. So h of x equals cosine 2x. Instead of 1/2, we got a 2. Did our amplitude change? No, that's still a 1. Our period is going to be 2 pi over 2. So our period here is a what? Pi. So that means from 0 to pi, I'm going to get one complete cosine curve. It's going to go down and then all the way back up. So let's figure out where our key points are going to happen. So I take the period, which in this case is pi, and I divide it by 4. Which really there's nothing else you can do over there. It's just pi over 4. So if you think back to our radian day, pi over 4 is how many degrees? 45. So that means our key features are going to happen at 0, and then at 45, which is going to be halfway between my 0 and my 90, and then at 90, and then at halfway between 90 and 180, and then at 180. So every little half spot here, we're going to have a key feature or a key point. So we get a lot more points on this graph than we did the last one. So again, it starts at 1. At my next little tick mark is going to be 0, then -1, then 0, and then back up to 1, 0, -1, 0, 1. So that's what the right side of our graph would look like. And of course, we have to repeat that over here on the left. So now you kind of see the difference of what happens when you go from a 1/2 as a b value to a 2 as your b value. As I said, for that 2, that means it goes down and up 2 times in one typical period. Okay. So this next part, we're just going to practice finding our period and then our key points. Like how far apart are your key points going to be? So like our second one here, our key points were pi over 4 apart. So figure out our period first. So that would be 2 pi over 1/2. So what does that clean up to equal? 4 pi. So our period is 4 pi, so that means you're going to get one complete sine curve between 0 and 4 pi. So then our key points, you again take your period, divide it by 4. So 4 pi divided by 4 gives us pi. So that means that every pi, that's when you're going to put another little tick mark. That's another one of your important points there. All right, so again, let's try the next one. Let's figure out our period first. So it's going to be 2 pi over what? Just the 4, not the x. So that cleans up to give us pi over 2. So our period is pi over 2. So that means between 0 and 90 degrees, you're going to get one entire cosine curve. That's going to be a tight curve. So then our key points would be our period divided by 4. So we're going to have to do a little keep, change, flip action here. This is really 4 over 1. So you have a fraction divided by a fraction. So pi over 2 times 1 over 4 gives us pi over 8. So our key points are going to happen at every pi over 8. And then our third one here. Again, let's figure out our period first. 2 pi over what? Pi over 12. I'll give you guys a couple seconds. Let's see if you can clean that up, figure out what our period is. Yep, always 2 pi over your b value. Not 2 pi squared. Well, I really want some pi now.
I haven't had pi actually in like 3 years. I don't really like pi.
Isn't that a weird thing?
No, it doesn't.
It's just a number. It's not, pi's not there anymore.
No, pi doesn't cancel.
It does.
24.
Period would be 24. Because we would have 2 pi over 1. And then flip that.
Oh, we have to flip the other one?
Yeah, keep, change, flip. Pi's cancel, I get my 24. And this is an example of one that you would get with like a word problem that they would be dealing with time. So your period would be 24, like 24 hours or 24 months or something along those lines. So then for our key points, our period, which was 24 divided by 4, our key points would happen every 6. And again, it's whatever they're talking about, every 6 seconds or every 6 hours. Okay, so graphing by hand. Now we're going to start getting into our little bit more complicated trig curves. So the steps that we want to follow is, number 1, if you have it, you want to sketch your midline first. So if I look at my graph here, though, does this one have a midline? No, because there's no plus or minus anything at the end. So your midline is just your x-axis. You don't have to draw anything in for that one. Second, you want to calculate your period. So what is our b value for this question? It'd be 1/2, so 2 pi over 1/2. That would give us a period of what?
4 pi.
4 pi.
Is that a common one?
Very, yes. So number 3, you want to find any key points and put little tick marks on them. So remember, to find our key points, you take your period, which was 4 pi, divide it by 4. So where are our key points going to be?
Every pi.
Every pi. So I'm going to put a line at 0, pi, 2 pi, negative pi, negative 2 pi. That's where our highs and our lows are going to be. So then step 4, you're going to graph your key points and connect. So here, we have to keep in mind, for our key points, we have an amplitude of what? 4. So we're not going to go 1 to -1. We're going to go 4 to -4 for this one. Sine curve always starts at 0. So at 0, 0, there's my first one. Then it would go up to 1, but our amplitude is 4, so it's going to go up to 4. And then back down to 0 at 2 pi. Negative pi would be at -4. And negative 2 pi is at 0. And so that would be our curve there. Really not too bad. I know. All right, let's take a look at our next page, our last page here. So we are graphing sine, or -2 sine of x plus 1 using the graph that they gave us from -2 pi to +2 pi. Now, for some reason, I don't know why that's there. That should be 3 pi over 2. My computer didn't like me and it wanted to put a giant 2 pi there, but it's really 3 pi over 2. So let's take a look at our important information. What is our amplitude based on our equation? 2. Our period would be 2 pi over b. What's our b value? 1. So our period would just be 2 pi. Our phase shift, do we have one? No. Your hint, you have a phase shift if it would have something kind of like that where it's in parentheses with your x. We don't have that. There's no phase shift. None. We do have a wrap line this time at y = 1. What would our range be?
-1, -3.
Pretty sure it was -1, 3. So one other thing for us to figure out that's not part of our box. Key points. Again, it's 2 pi divided by 4, because 2 pi was our period, so period divided by 4. Not 2 pi. Pi over 2. So every pi over 2. So basically every line on my graph here, I'm going to have a key point. Now, as we said on the last page, if we have a midline, we have to draw that first. This time we do have a wrap line at y = 1. So that's a horizontal line that we always draw in as a dotted line. But that line gets drawn in first. So now, instead of using your x-axis to get your zeros, you have to use that wrap line. We've just taken our graph and we've moved it up. So our sine curve would normally start at 0, 0, but now it's up 1 at 0, 1. So then our curve would go up normally, but because it's negative, which way is it going to go this time? Down first. So it's going to go down 2 from your line here, your wrap line. And then back up to the line. Then up 2 from the line. And then back to the line. So as opposed to normally going up, because it was negative, the sine curve went down first. And then again, we continue the pattern over on the other side. And that gives us our beautiful sine curve. So our steps in doing so much like when you graph it, first thing you have to figure out is there a midline? Now when you have the graph and you're trying to find if there's a midline, the way we do that is your high value plus your low value, and then you divide it by 2. You're trying to find the middle. So our high value is 5. Low value is -1, and it's divided by a 2. So our midline is where? 2. So then I actually go through, and I strongly recommend actually drawing it in there, because it's going to make your life so much easier. So once we have our midline, next thing we want to find is our a value. So from the midline up to the highest part, that's your a value. How far apart is that? It's 1, 2, 3. So our a is 3. Third step, we have to determine whether this is a sine or cosine curve. So again, here is our midline. If it were sine, it would start right there. But this one doesn't start there, so therefore this is what kind of curve? Cosine curve. Step 4. Shh. We need to find our b value. Paul. All right, so step 4, we got to find our b. This is a little trickier. So what we have to do is we have to start with the fact that we know the period is 2 pi over b. So if we look at the graph The period is the time it takes for it to complete one entire curve. So my cosine curve starts here, it goes down, comes back up, and it stops here. So how long did that take? From 0 to 4. So our period was 4. So now we kind of have like a little equation that we're trying to solve here. I'm going to put 4 over 1. I'm going to cross multiply. So my 2 pi equals 4b, divide by 4. So our b value is a pi over 2. Step 5, you got to see if there's a phase shift. Did it move left or right any? This one did not. Generally, they're not going to when they give you the picture and they want you to write the equation because phase shifts are very difficult to see. So now we can finally go ahead and write our equation, which if you remember, goes off of what we had at the beginning. A is out in the front. This one's a cosine curve. So I'm just following along with that we had. So we said our A value was a what? 3. So this is going to be 3 cosine. We found our B value to be pi over 2. And then we'll put the x after it because we said there was no C. There was no phase shift. So I don't need the parentheses around that. And then our midline, our D value, was the very first thing we found, was a plus 2. So that would be the equation of our curve there. All that work for that.